Consider the following series given by the sum from n going to 1 to infinity of ln of n over n squared. We want to find out if this series is convergent or divergent. There are many tests that would tell us if it's convergent or divergent, but here we want to apply the integral test. Okay, so let me write this one here. So in this case, this series going from 1 to infinity of ln over n squared. The general term is an ln over n squared. Okay, so this series is positive, except when n is 1, which is equal to 0. So an is bigger than 0. Okay, so it's gonna be decreasing. Okay, so it's decreasing, and it's also when it's increasing when n is equal to 2. Okay, so in this case, if we define f of n as a of n, okay, so we have this function and we let f be defined on this interval. Okay, so we have f is positive because the series is positive. The f is decreasing, okay, and it's continuous on this interval. Therefore, according to the integral test, this series, the nature of this series is the same as that of the integral of this function between 1 and plus infinity. So that's what we're going to compute. We're going to compute the integral between 1. So first, let's choose f. F is given by f of x ln of x over x squared. So given that, we have ln of x over x squared dx. Okay, so we want to see what we get from this one here. But first, let's see if we can compute an antiderivative of this one. Okay, so let's use it without the bounds. So ln of x, we see that 1 over x squared is okay. I see now. If we define u prime as 1 over x squared, then u is minus 1 over x. And if we define v as ln of x, then v prime is 1 over x. Okay, therefore we have, this is u prime v is uv minus uv prime. So this is gonna give us uv, that means minus ln of x over x minus uv prime. Let's get this minus with this minus. uv prime, so u is 1 over x, v prime is 1 over x. So we have minus ln of x over x minus 1 over x squared. Okay, and 1 over x squared is just minus 1 over x. This let us evaluate here. Now we go back and we see that 1 plus infinity of ln of x over x squared dx is the limit as t equals to infinity of minus ln of x over x minus 1 over x between 1 and t. Okay, so we're gonna evaluate 1 first. At 1 first, because of the minus, we're gonna get rid of the minus. So we have 1 minus ln of t over t minus 1 over t. As t goes to, let me not forget the limit, as t goes to infinity. So here, this is 1, this is 0, and this is 0, so I have 1. That means my integral here is convergent and it's equal to 1. Okay, so if this one is equal to 1, that means, let's call it I. So I is equal to 1. I is equal to 1 means that it's convergent. Therefore, my series is convergent as well. So by the integral test, we have shown that this one is convergent since the integral is convergent. Thank you.